Hey everybody. So in this video, we are going to look at our AKS portfolio for 6D and 6E. We're going to start off with 6D. It says, I can construct an explanation regarding the relationship between the structure and properties of acids and bases. So if you go ahead and you look at your portfolio, you're first given all of these different properties, descriptions, characteristics, even some models to separate into your Venn diagram for acids and bases. Before we get to that, I want to talk to you about the pH scale. Okay, so here's an example of the pH scale right here. Notice it goes 0 to 14. This is going to tell you how acidic or how basic something is. Another word that you will hear for basic is alkaline, okay, like how much alkalinity it has. So if it is from 0 all the way to 6.9, these are going to be considered acidic, okay? 7.0 is neutral, and then anything over that, so 7.1 all the way to 14 is basic or alkaline, all right? So if we're looking over here at the answers filled in for your Venn diagram, we can start to look and see what acids and bases truly are. So if we're looking at the acids, remember that's from anywhere from 0 to 6.9. Okay, this section right here. They're going to taste sour. And notice on your lemon juice is one of the examples. So anything that you think of like, oh, that's a citrus fruit, and of course it's very sour tasting, right? Lots of other things are acids as well, but that's a really good example. It's going to be watery. It's going to turn blue litmus paper red, and I'm going to show you an example of that in a second, okay? Reaction with carbonates to form O2, CO2, which is just carbon dioxide bubbles. Reacts with metals to form hydrogen gas, and reacts with bases, separates into hydrogen ion, which is H plus in water. This is very important, this one right here. All right, so it does separate out, and it will release hydrogen plus ions, okay, so cations that are in the form of hydrogen out into your solution, and that does make it acidic. The more that it's releasing, the more of those H positives makes it more and more acidic, okay, and it has a pH lower than 7. So when you're looking at the pH scale, the closer you are to 7, which is neutral, the weaker of an acid it's going to be. So the farther you get away from neutral being 7, so the lower the number, the more acidic it's going to be, which means the more H plus ions are in your substance, okay? Now, we're going to switch and we're going to go over to bases. So bases, remember, are 7.1 all the way up to 14. Bases work exactly the same way. So the closer you are to 7, the more weak of an acid, or weak of a base, which is like the alkalinity is going to be very, very low, okay? And the farther away you get from 7, so the higher the number you are, closer to 14, the more and more basic, the more and more alkaline it does become, okay? So bases, they have a bitter taste to them. If you think like coffee, things like that, that's very, very bitter tasting. It's kind of gross on your tongue, right? That's what bitter is. A lot of things like bleach and cleaners and soap are bases. Most people haven't tasted those things because a lot of them are poison to humans. So that's why I'm comparing it to coffee, because a lot of people have at least tasted the taste of bitterness from coffee before, okay? Slippery fill. Just think of soap. Soap feels very slippery to the touch. Bases will also feel slippery, okay? It does turn red litmus paper blue, which we will discuss a little bit more in a second. It does not react with carbonates, reacts with acids, yes. And then this one is extremely important. It separates into hydroxide ions, which is OH negative in water. So it's an anion, right? So, you know how acids, they release the H positive. Well, bases actually will separate out into OH negatives, okay? So these are the difference between the two. The more and more OH negative you have going on, the more alkaline or basic your substance is going to be, okay? And then, of course, the pH is going to be higher than 7. You can look at some of these things that they have in common as well. They all are compounds. They react with litmus paper in some form or fashion, and I will show you that in a second, but let's continue on. So it says, construct an explanation regarding the relationship between the structure and properties of acids and bases. All you had to do here is circle. If I'm looking at a chemical formula, right here, I can see this is my reactant side, here's my product side. This H positive is telling me, hey, this is an acid, right? It is releasing H positive, which means it is acidic. Okay, so you can go ahead and circle that acid. This one right here, my reactant side, here's my product side. On my product side, I have OH negatives. If it's releasing OH negatives, I know this is going to be basic or alkaline. So go ahead and circle that one. All right, now you're given a scenario. The scenario says a chef observes the changing of color of a head of cabbage from purple to pink when placed into soup. Using the data, construct a claim evidence reasoning combination that best explains the observation of the chef. Well, in order to know this, you first have to know about cabbage indicator. So what cabbage indicator is you take a red cabbage, which actually they look purple, okay? You cut it up, and I put the directions here. Roughly chop it, you boil it for a few minutes. The water is going to turn purple, and your cabbage is going to look really gross, and it's going to stink really bad. You can strain it out, and then you take all the liquid that you strained out, and it's going to be purple, and that's your indicator. So purple is going to be your neutral, which is 7, okay? Now, if I were to put any kind of substance with my indicator, like just pour a little indicator in it, it's going to change colors depending on if it's an acid or a base. You can see here that if it's acidic, it's going to go light purple to pinks to all the way to reds. And then if it's basic or alkaline, it's going to go to like a deep purpley blue, all the way to green, yellow, and then even like kind of slightly a tinge orange, right? So based off of these, I can tell whether it's going to be acidic or basic. This is a chef. He just put this purple cabbage into his soup, and he's saying, hey, it turns to pink. It's a purple cabbage, right? We call it red cabbage, but it's a purple cabbage, and it turned it pink. So if it's turning it pink, pink's around here, we can see that it's definitely an acid. You guys are given this up here. So you can see that pink is at a pH of 3. pH of 3 is definitely acidic. So it has to be 1. The soup must be acidic, okay? Okay, we are going to now head into 6E. I can plan and carry out investigations to detect patterns in order to classify common household substances as acidic, basic, and neutral. Now you can do this in a lot of different ways, and we're going to discuss a few, all right? But here's a scenario you're given. It says your mother is spring cleaning at your house. She comes across various bottles of substances that you would like to organize them, design an experiment to find which substances are acid, bases, or neutral to help her out. So I'm going to go to a simulation and show you one of them now. Okay, so as you can see on here, I have a substance that is in this container. I clicked on it. It's water, just H2O, nothing more. And here is my pH indicator. Well, I know water should be 7, okay? Water should always be pretty much neutral. And then I have a piece of pH paper. When I stick this pH paper inside of my substance, it's going to turn one of these colors, and it lets me know what the pH is for that substance. So I can tell, is it acidic, basic, or neutral? So I'm going to go ahead and I'm going to stick it in, and then I can match it up. And I could say, okay, this water is kind of in between a 6 and a 7. So it's pretty close to neutral, which is accurate. Water should be fairly close to neutral. Okay. Now we're going to look at a strong acid. A strong acid should be around 0, 1, 2, maybe even 3, right? For it to be a strong acid. So let's see if this comes out correctly. And if I check it, yeah, I'm about at a 2. I mean, that looks like a 2 to me. What do you guys think? I think that looks like a 2. So let's try in comparison what a weak acid would look like. Weak acid is going to be anywhere between like a 4 to a 6.9, right? So if I dip this in, I can match it up. Okay, so yeah, I would say so. I would say it's between like a 5 and a 6. So that is pretty on point. A strong base. Remember, the stronger the base, the higher the number it is because we want it farther away from 7, right? To get that strong base going on. So anywhere between like probably 10 to 14, maybe even 11 to 14, I would consider a strong base. So let's see what they say it is. And yeah, they're going to say, I think that looks like a 12. So that's definitely a strong base. And we're going to go ahead and try a weak base. Dip it in. I should be getting anywhere from 7.1 to 10-ish, right? And yeah, I'm going to say that looks like in between a 9 and a 10, most definitely, for a weak base, okay? Okay, the last thing to know is the litmus paper test. So we just looked at pH paper, which is different, right? Litmus paper is the last one. These are going to be strips of paper. They're called blue and red. Now, if you start off with a blue strip, it looks like this, just solid blue, okay? When you dip it in a substance, if it turns red at the end, and I know this looks pink, and it will always look pink, but they call it red, okay? So if it turns red at the end, it's telling you, hey, it's an acid. This unknown substance is an acid, okay? Now, if you take a red strip of litmus paper that looks like this originally, even though I know it looks pink, we call it red, and you dip it into a substance and it turns blue, that means that it is a base, okay? So I remember this because if it turns blue, blue starts the B, base starts the B, and that's just been my way of remembering it. Hopefully it will help you, okay? So this is another way to determine the pH of those household substances. So you've had 3 ways that you can do this at home. One, you can use litmus paper, right? If it turns blue, it's a base. If it turns red, it's an acid. You can use pH paper and you can dip it in the substance. You can match up that color between 0 and 14 to see if it's acidic or alkaline. Or you can use the red cabbage, cut it up, boil it, strain it, use that liquid as an indicator to then go ahead and test the substances to see how acidic or basic they are. So use any one of those methods to fill out this AKS portfolio. All right, thanks guys, bye.